Okay, so this first one, very simple. 5.00 moles of sodium. And I want to go to the moles of Cl2. That's stoichiometry from the moles of sodium. Where do I find this relationship between moles of sodium to moles of chlorine? Excellent. The balanced chemical equation. That's where I find it. So how many moles of sodium do I have? How many moles of chlorine? 1. Okay? That's the stoichiometry. Okay? That's the relationship to do the stoichiometry. Now, we're going to go look at this next one then. And I'm starting with, for number 3, I'm starting with 5.00 moles of sodium. It wants me to go to the grams of sodium chloride. Can I do that in one step? No. What do I have to do first? Moles of NaCl. The other thing, right? Moles of sodium chloride. That's the stoichiometry step. Moles of one thing to the moles of something else.
So the excess of that doesn't matter.
Excellent. This excess of chlorine has no bearing on this question. What excess means is that there is more chlorine than we would ever need. So for example, here I have 2.5 moles of chlorine that are needed to react with 5 moles of sodium. Well, what if I had 10 moles of chlorine? Would I use 10 moles of chlorine? No, I would only use 2.5 moles, right? So that means 10 moles of chlorine is in excess. There's excess chlorine, more than I would use. So what determines how much sodium chloride I produce? This, the 5 moles of sodium. Okay, not the 10 moles of chlorine, because there's excess of it. So that's all this means. Excess means it's not important to the reaction, or the calculation of the reaction. It's important to the reaction, just not to the calculation of the product. Okay? So it's in excess, so we don't need it. So we're going to go from the moles of sodium to the moles of sodium chloride from the moles of sodium. Okay, so if I look at my chemical equation, the coefficients for that, 2 sodium chlorides for every 2 sodiums. That's the stoichiometry step. It comes from the balanced chemical equation. Have I answered the question? No. What do I need to do to answer the question? Convert the sodium chloride to the grams of sodium chloride from the moles of sodium chloride. Right? Good. So, whenever grams and moles are together, moles are what? 1. Because I want to know how many grams of sodium chloride there are in every 1 mole of it. But people want to put 2 there because the coefficient is 2. Don't. You already did it right here. Don't do it there. I don't want to know how many grams there are for 2 moles. I want to know how many grams there are for every 1 mole. So please just put a 1 there. Whenever it's grams and moles, moles are always 1. Whenever it's mole to mole, that's when I go here to the chemical equation and I find the coefficients for the mole to mole stoichiometric relationships. That's what I use there. But when it's grams and moles, moles are always 1. Where do I find the grams? The periodic table. 58.3 grams of sodium chloride for every 1 mole of it. Okay? That's how I do this one. Now let's look at number 4. On number 4, I'm starting with 5.00 grams of chlorine, and I want to go to the grams of sodium. Can I do that in one step? I cannot. How do I know? Because grams is involved. Whenever grams is involved, there's more than one step. If it was in moles, and I was going to the moles, it would be one step. But because it's grams, and I'm going from one thing to another thing, from chlorine to sodium, I know that there's more than one step. Okay? So, what is the first thing I need to do if I start in grams? I have to get it to moles because I cannot do the stoichiometry if it is in grams. So I can convert to the moles of Cl2. So from the grams of Cl2, I go to the moles of Cl2. Now I can do the stoichiometry. Now I can convert from Cl2 to the moles of sodium. Okay? That's the stoichiometry step. But I can't do it in grams. I have to do it in moles. And I can't go from moles of Cl2 to the grams of Na. I'm saying all these things because this is what I see all the time. Okay? Okay? So I can't go from moles of Cl2 to the grams of Na. I can only go from the moles of one thing to the moles of something else if I have a balanced chemical equation, which I do. So I can do that for this. But now that I'm in the moles of sodium, have I answered the question? No. So, to answer the question, I need to convert to what? Grams of sodium. Okay? Once I know the process, this is my process, right? Now all I have to do is drop my units. Okay? What units go down there? What units go down there? And down here? Okay, now that I have everything filled out by units, now that I've done the dimensional analysis, I can easily put my numbers in. Grams of CO2, moles of CO2. What are the moles if it's with grams? 1. Grams of sodium, moles of sodium. What number do I put for moles? 1. Grams of CO2, for every 1 mole of CO2, how many grams is it? So where do I find that? The periodic table. 35.5 times 2, 71. 70 is close. 71. You could use 70.
Yes, 70 plus 1.
Okay? So, moles of sodium, moles of Cl2. Where do I find that relationship, that stoichiometric relationship? The balanced chemical equation. I have 1 Cl2. Highlight them. I have 1 Cl2 for 2 sodiums. How did I know to go to the balanced chemical equation for this one? It's a mole-to-mole relationship. Okay, good. What do I put here?
22.9 or 23.
Okay, we'll just use 23. 23 grams for every 1 mole of sodium. That's the process. Okay? So what I want you to try to understand and visualize with stoichiometry is whenever I'm converting from one thing to another thing, I have to do it in what units? Moles. Can I do it in grams? No. So you have to convert the grams to moles, and then you can convert from one thing to a completely different thing if you have a balanced chemical equation. And then sometimes, to answer the question, I convert back to grams because they want me to. Okay? But if they don't want you to, then don't. Just leave it in moles. All right. So that's the process. Now, I have a worksheet that I'm going to hand out that will help us practice what we just did. Okay, so look at the first one. How many moles of HF are needed to react with 0.3 moles of Na2SiO3? Let me ask you, how many steps? How do you know? It's just in moles, no grams are involved, so just one step. B, how many grams? Yes, I'm going to use the balanced chemical equation. These are balanced. Okay? They have coefficients, so you know they're balanced. Okay? They're not going to put fake coefficients there to try to trick you. If it has coefficients, it will be a balanced chemical equation. Okay? B, how many grams of NAF form when 0.5 moles of HF react with excess Na2SiO3? More than one step, right? Because I'm going to have to go first from the moles of one thing to the moles of something else, and then to the grams to answer the question. So it's going to be 2 steps. C, how many grams of Na2SiO3 can react with 0.8 grams of HF? 1 step? 2 steps? 3 steps. Okay? Because what's involved? Grams. And I'm going from the grams of one thing to the grams of something else. Can I do that directly? No. I can only do that in what units? Moles. Only in moles. So that means I'm going to have to take this 0.8 grams of HF and convert it to what? To moles. Then I can do the stoichiometry. Go from HF in moles to the Na2SiO3 in moles. But that doesn't answer the question. So how do I answer the question? I convert that to grams. So do you see how that's 3 steps? So, but that's the most steps basically that you would do for a stoichiometry problem, except for one down here where it's not quite in grams, it's in kilograms. So you're going to have to put it in grams. Okay? All right. So go ahead and get started. I'm going to be coming around, checking on you. Okay, you guys, when you get to this question, number 4, okay, and it asks which reagent is the limiting reagent, okay, then this is how I want you to approach that, okay. All I want you to do, is I want you to start the equation of 1.85 moles of NaOH, okay, and convert it to the moles of one of the products. Okay, it doesn't matter, let's just say water, moles of H2O from the moles of NaOH. And then do the same thing, 1.00 moles of carbon dioxide to the moles of H2O from the moles of carbon dioxide. Okay, fill it out and then answer that question. You're going to get 2 different answers. Whichever one is the lowest is your limiting reagent. Okay, use that one here in B. So whichever one is the lowest, use it in B to determine how many moles of Na2CO3 can be produced. Okay? Thanks. Okay, so that's what you're going to do there. Then, in number 5, what is the theoretical yield of C6H5Br? You're beginning with 2 different numbers. You don't know which one is the one that is actually going to give you the right number because one is limiting, one's in excess. Remember, excess is the one that doesn't matter. So we have to figure out which one's in excess. So the way we do that is we start with our 30.0 grams of C6H6 and convert it to C6H5Br, grams of C6H5Br. And then start with your 65.0 grams of Br2, convert it to C6H5Br. Whichever one is the least, gives you the least amount, is the one that was limiting. The other one was in excess. That's why it gave you more than you should have gotten. So the one that was in limiting, that's the one that you use down here. That will be your theoretical yield, okay, of C6H5Br. So take your theoretical C6H5Br and find your percent yield by taking your actual 56.7 divided by your theoretical, whatever you find for the one that was limiting here in 5, and then times 100. Actual over theoretical times 100. Your theoretical comes from letter A. Okay, that's the one you're going to use here. Actual is this number. Okay? Yeah. And then you'll ask me again when you get there because you forgot everything I just said. How much? That much? Okay, so we're going to go through these. We're going to set them up. Make sure you're doing it right. Okay. How many moles of HF are needed to react with 0.3 moles of Na2SiO3? So I start with my 0.300 moles of Na2SiO3. And I'm going to convert that to the moles of HF. Whoops. That's weird. From the moles of Na2SiO3. Okay, and their relationship comes from here. There's one of these for every 8 of those. So 8 to 1. What did that come out to be? 2.4? 2.4 moles of HF. Okay, next one. 0.500 moles of HF is what I start with. I'm going to go to the grams of NaF. So I'm going to first go from the moles of HF to the moles of NaF to the grams of NaF. Drop my units, moles of HF, moles of NaF. Grams of moles, moles are 1. The grams of NaF were what? How many grams for NaF? Say it again. 42. Okay. Moles of HF to the moles of NaF, I come here. NaF is 2. HF is 8. Okay, so that's what I'm going to use there. Mole and mole relationship, I always go to the balanced chemical equation. Okay, what did that come out to be? 5.25 grams of NaF. Okay. Okay, so now I'm going to go from the grams of Na2SiO3 to the grams of HF, or from the grams of HF to the grams of that. So 0.800 grams of HF. The first step has to be to the moles of HF, then to the moles of the other thing, which is Na2SiO3, then to the grams of Na2SiO3. Okay? What did that turn out to be? 0.6, right? 0.61 grams, okay, is the answer that goes there. But that's the process that you should be following. Okay, how many moles of CO2 are produced when 0.4 moles of C6H12O6 reacts in this fashion? So 0.4 moles of C6H12O6. And I want to go to the moles of CO2 from the moles of C6H12O6. Okay, what did that turn out to be? 4.8? Oh, 0.8. Okay, how many grams of glucose are needed to form 7.5 grams of methanol? So 7.50 grams of ETOH. And I'm going to convert it from the grams of ethanol to the moles of ethanol, then to the moles of glucose, and then to the grams of glucose. Okay? So that's the process. What did you guys find it to be? 14.67 grams of glucose. Okay? So, now I'm not finishing everything because remember here, for all these, I just have to drop my units and then fill it in. Grams of moles, moles are 1, grams are from the periodic table. Mole to mole relationships I find on the balanced chemical equation. But I want to show you the process because that's the hardest part. The hardest part is finding this process. How many grams of CO2 when 7.5 grams of ethanol are produced? So 7.50 grams of ethanol. How many grams of carbon dioxide? So grams of ethanol to the moles of ethanol to the moles of carbon dioxide to the grams of carbon dioxide. Okay, what'd you guys find? 7.17? Okay, if you're getting a different answer, then make sure you're checking that because I think there's consensus on that. Good. Okay, calculate the number of grams of carbon monoxide that can react with 0.15 kilograms of iron to iron 3 oxide. So 0.150 kilograms. I need to convert the kilograms to grams of Fe2O3. Fe2O3. And then from the kilograms, I can go to the moles of Fe2O3. And then from the moles of Fe2O3, I can convert to the other thing, which is carbon monoxide. Moles of carbon monoxide, then to the grams of carbon monoxide. That's the process I would follow. Good. 1,000 grams for every 1 kilogram. That's right. Nope, that's right. Okay? So what did you guys find for that?
78.93 grams.
Is that what you got? 7.5? Close enough. That's probably just a difference in how you calculated your Fe2O3 or something. That's close enough. Good. Okay. So, calculate the number of grams of iron and the number of grams of carbon dioxide from 0.15 kilograms of Fe2O3. What did we calculate? We carbon monoxide up here. Okay, so here we're going to start with 0.150 kilograms of Fe2O3. Okay, and we're going to go to the grams of Fe2O3 to the moles of Fe2O3 to the moles of the other thing. So for the first one, I would go to the moles of iron, and then for the second, I would write a second reaction or equation, and I would go, everything would be the same at first, and then I would go to the moles of carbon dioxide, and then to the grams of iron and the grams of carbon dioxide. So you have two different equations there. Okay? All right. We'll see you guys. Have a good one. If you want.